Hello, we'll be discussing Chapter 14, Money and the Economy. Okay, so we've talked about the Consumer Price Index in Chapter 6 when we talked about how this index is used to measure changes in the price level over time. So suppose P is the price level as measured by the CPI. So when we say P is the price level, basically it's the number of dollars that's needed to buy a basket of goods and services. So if P is the price level, the value of a dollar measured in terms of the goods and services that we can buy is given by 1 over P. So here's an example. Suppose the price of an ice cream cone is $1. Then the value of a dollar is one cone. So here we're saying value of a dollar is 1 over P. The P is 1, so 1 over P, 1 over 1 is equal to 1. So the idea is with $1, if the price of each cone is a dollar, with $1 we can buy one entire cone. Now, if the price of the ice cream cone increases to $2, then the value of a dollar is 1 over P, so 1 over 2, which is 1/2. So now what we're saying is with $1, now we can only buy 1/2 of a cone because each one's now $2. So similarly, if the price of the ice cream cone increases to $3, value of a dollar, 1 over P, so 1 over 3 is 1/3 of a cone. So now we're saying with $1, now we can only buy 1/3 of a cone. So we can see here that as the price increases, so the higher the price or the higher the price level, if we use an index to measure the overall price level, so the higher the price level, the less each dollar is worth in value in terms of the purchasing power. So intuitively, what it means is the higher the more expensive things are, the less each dollar stretches in terms of what it's able to buy. So here, for example, when initially the price of an ice cream cone is $1, then with a dollar, we can buy one entire cone. If the price were to increase to $2, now it's saying with $1, we have to find somebody else who also has a dollar, and now we split the cone with a dollar each. So each dollar, in terms of what it's able to buy, is less as the price goes up. Okay, let's look at monetary equilibrium. So we'll look at the supply and demand for money. And here with money, we're saying money in its liquid form. So supply and demand for money rather than holding the money in terms of other assets. Okay, so on the x-axis, we have the quantity of money. And notice here we have two y-axes. So on one side here, we have the value of money, which is 1 over P. And then the second y-axis here is measuring the price level P. So here we have P, and then this is simply 1 over P, which is the value of money. So we can notice that if the price level, for example, is 2, then the value of money, 1 over P, so 1 over 2 is 1/2. And then to pick another point, let's say that the price level is at 4. Then the value of money, 1 over P, so 1 over 4 is 1/4. So whatever we have as the price level, the value of money is simply the reciprocal. So if this is P, then we get 1 over P, which is the reciprocal here. Um, So what it means is if the value of money is low, that indicates that the price level is high. Or if the price level is low, the value of money is high. So these are the opposites. Um, so intuitively, when we have lower prices, each dollar has a lot of value because each dollar is able to purchase more. And then when the price level or when prices are high, each dollar is worth less. So with higher prices, the value of money is lower because it takes more and more dollars to buy each thing. The more expensive the price level is, or the higher the price level is. Okay, so in our monetary equilibrium in this graph, we can see that the supply curve, let's look at MS1, this is money supply 1. So the supply curve is vertical. So here we're saying that the supply of money is a policy variable that is fixed by the Fed. So the Fed could increase the money supply from MS1 to MS2 if they wanted to, or they could decrease the money supply, and in that case, the money supply curve would shift to the left. So the Fed can increase or decrease the supply of money so the curves can shift left or right, but the money supply is vertical because it's independent of the price level. So it doesn't matter if the prices are low or if they're high, and it doesn't matter if the value of money is high or low, but the money supply is independent of the price level. So here in our example, suppose that the money supply initially is fixed at 1,000. So here we're at MS1 and the amount of money we have in circulation initially is 1,000. If we look at money demand, which is this curve over here, we can see that the demand curve for money is downward sloping. And it's downward sloping because as the value of money falls, so going across this way, so moving across the right to the x-axis, as the value of money is lower and lower, we need the demand for the money, the quantity demanded increases. So the demand curve is downward sloping because as the value of money falls, so as we have less and less purchasing power, we need more money to buy things. So there's a negative relationship between how much money you want to hold in liquid form and the prices. So here, if let's say there's a point on the demand curve. So this is our demand curve over here. Let's say there's a point up here. So what it's saying is when the price level is lower, we need less money to buy things because with lower prices, we need less cash in order to buy these things. And as we go across the right over here, we can see as the price level is higher, we need a larger quantity of money in order to buy things because of the higher prices. Now we need more dollars to buy those things because of the higher prices. So that's why the demand curve is downward sloping. Okay. Okay, so with the initial money supply fixed at $1,000, what is the equilibrium price level? Well, the equilibrium is going to be where the money supply and the money demand curve intersect. So this is MS1, this is MD1. So here we see there's an intersection at this point, point A. So the equilibrium price level is 2. And this corresponds to the value of money at 1/2. So the equilibrium price level initially is at 2. And then now, suppose the Fed doubles the money supply to 2,000. So initially we had $1,000 in circulation. Now let's say the Fed doubles the amount of money in money supply. So we have 2,000. What is the equilibrium price level now? Well, so that's going to be the intersection of MS2 and MD1. So we can see that the two curves intersect at point B. And at point B, the new equilibrium price level is 4. So here we can see that the price level, when the Fed doubles the amount of money in money supply, the price level also doubles from 2 to 4. So is this a coincidence? Is it a coincidence that doubling the money supply doubles the price level? Answer is no, not really. The quantity theory of money tells us that if there's any changes in the quantity of money, how much money we have in circulation, that's going to lead to proportional changes in the price level. So as another example, if instead of doubling the money supply from 1,000 to 2,000, let's say we tripled the money supply from 1,000 to 3,000. So then we would have the money supply curve out here. We would notice then that the price level would go from 2 to 6. So if we triple the amount of money in circulation from 1,000 to 3,000, the equilibrium price level we would expect would change from 2 to 6. So if this multiplies by a factor of 3, then the equilibrium price level also would multiply by a factor of 3. So that's what the quantity theory of money tells us. So essentially it's saying that whatever prices we see depend on how much money we have in circulation. The more money we have in circulation, um, it's just going to lead to higher prices for the things that we have. Okay, so when we look at the velocity of money, you've probably heard of the term velocity in like a physics class. So in physics, velocity is the change in speed at which an object travels. Um, so in economics, velocity has a similar concept. So the velocity of money is the rate at which money changes hands. So it's similar to the change in speed. It's the rate at which the money changes hands from one person to another. And it's given by this equation. So velocity is given by P times Q over M. So V is the velocity of money. P is the price level as measured by something like the Consumer Price Index or the GDP deflator, which track changes in the price level. Q is real GDP, so it's the quantity of production or real GDP. And then M is the quantity of money. So you can think about it in terms of the money that we have in circulation. So the velocity of money is given by P times Q over M. Let's use this formula in an application. So seeing what this means. Suppose in our economy, for simplicity, suppose we only produce pizza and we produce 100 pizzas in a year. Each pizza sells for $10 and we have $50 in our economy. So what is the velocity of money? Okay, so we're going to use this formula and let's plug in what we know for each of these variables. So P is the price level. It's the overall prices of things. Here we only have pizza in the economy, so it's just the price of pizza, which is 10. So we can substitute in 10 for P, the price. Q is the quantity of production or real GDP. So here we're saying we produce 100 pizzas in a year. So Q is equal to 100. And then M is the quantity of money. And we know that we have $50 in our economy. So that's M. So we're just solving for V and plugging everything in. So V is equal to P times Q over M. So we have the price of each pizza, which is 10, times the 100 pizzas, which we produce in 1 year, divided by the $50 we have in our economy. So 10 times 100 is 1,000, divided by 50 is 20. So here the velocity of money is equal to 20. So the interpretation of this number is that each dollar bill of the original $50 that we have is used 20 times in the year. So we're saying each of these $50 changes hands 20 times in the year. So this should make sense because we know that in order to buy 100 pizzas at $10 each, this would cost $1,000. And we know that realistically, we don't just use each bill or each dollar once. With money, if you have like a $5 bill or a $10 bill, you could use that money to buy something and then somebody else gets it and they can use it to buy something else and so on. It's not like each bill gets used only once and then it's burned, right? So it gets used over and over again as it changes hands from one person to another. So here we're saying so if each pizza sells for $10 and we produce 100 pizzas, essentially this is going to cost $1,000 in all. And if we have $50 in our economy, each of these dollars is going to be used 20 times so that we can spend the $1,000 on it. So once somebody uses the $50 to buy pizza, the money changes hands until more and more people buy it. And pizza is the only thing that we're buying here. So each dollar bill gets used 20 times in the year. Okay. So we kind of just went over this. So we produce only pizza in the economy and we produce 100. So we found that the velocity of money is equal to 20, plugging all the variables in. So now suppose that the Fed buys bonds, which doubles the quantity of money in circulation from 50 to 100. So remember from chapter 13, when the Fed buys bonds, they're taking away those certificates from the hands of the public and actually giving them what the certificates are worth. So when the Fed buys bonds, it puts more money into circulation. And here we're saying this action will double the quantity of money in circulation from 50 to 100. So which other variable then also changes? So this is our equation for velocity. If we double the quantity of money here, m, from 50 to 100, you might be tempted to just put in 100 instead of 50 and then solve for the new v. But according to the quantity theory of money, velocity stays constant. So remember that the quantity theory of money says that the price level is based on how much money we have in circulation. So if there's any change in M, it corresponds to a proportional change in P. So what this means is if we double the amount of money in circulation from 50 to 100, then the other variable that also changes is P. So the price of each pizza then will also double from $10 each to $20 each if we put more money in circulation. So according to the quantity theory of money, it's not that we just plug in 100 here and solve for the new V. V stays constant. So rather, any change in the money supply M will cause a proportional change in P. So if we double the money supply, the prices also double. If we triple the money supply, prices also triple. Okay. So again, we have the velocity equation. V is equal to P times Q over M. So P is the price level, Q is real GDP divided by M, which is the quantity of money. So if we rearrange the equation by multiplying by M on both sides, so let's say this entire thing gets multiplied by M, so we get rid of the denominator and it cancels out the new numerator here, multiplying both sides by M. And then here we end up with V times M, or M times V. So rearranging this equation and multiplying by M on both sides, we can get rid of the M on the right-hand side, and then here we get a new M. So M times V is equal to P times Q. So from the pizza example, we found M times V. So the quantity of money was 50 times the velocity was 20, so this was 1,000. The $1,000 represents the consumer's total expenditure on pizza. So basically, in order to buy the 100 pizzas at $10 each, we spend a total of 1,000. So that's what we found. And this is similar to measuring the producer's total sales revenues, right? So however much the consumers spend on pizza is equal to how much the sellers are earning in terms of revenues. So it's the same idea. So it's like measuring GDP. There's the income approach and the expenditure approach. However much people are spending, that's how much the sellers are earning. So however much the buyers spend, that's equal to the amount that the sellers earn as sales revenues. So, so what it means is if each pizza is $10 and we have 100 pizzas, then the sales revenues from selling the 100 pizzas is 1,000, and that's also equal to the total expenditures, because we have $50 and each of the $50 is used 20 times. So here, given that these two sides equal one another, we can actually substitute in M times V for aggregate demand. So earlier we said aggregate demand is the demand for everything all at once. So it's equal to total expenditures if we use that GDP, the expenditure approach to measuring GDP. Right, so if you remember doing some of the calculations, we had P times Q. So given the prices of things times the quantity of production, we did P times Q to find the GDP in each year. So before we said GDP is P times Q, and another way to calculate GDP is by summing up the four components of GDP, which is consumption plus investment plus government spending plus net exports. So using the expenditure approach, total expenditures is given by the spending by households, which is consumption, spending by firms, which is investment, spending by the government, which is G, and then spending by foreigners, which is net exports. So in order to find GDP, earlier we had P times Q. Now we're saying we know that M times V is also equal to P times Q. So the quantity of money in circulation, M, times the velocity of money is equal to P times Q. So we can just substitute in M times V for P times Q. So we get that M times V is equal to C plus I plus G plus net exports. So M times V simply gives us another way to measure GDP. Okay, so we know that if aggregate demand is given by these four components, then changes in any of these four components could shift aggregate demand left or right. So for example, if households had an increase in spending, so that would be an increase in consumption, well, that would shift the aggregate demand to the right. Or let's say that the government were to increase income taxes so that we're left with less disposable income. Then we would cut back with household spending. So C would fall, and as a result, aggregate demand would also fall and it would shift to the left. So changes in these four components we know can shift aggregate demand left or right. Now we're saying, okay, if we can substitute in M times V for aggregate demand, so this is just another way to measure GDP or total spending. So how much money we're spending in the year is given by how much money we have in circulation times how much each bill is going to be used, or the velocity of money. So what this implies is that changes in either M or V can also shift aggregate demand left or right. So if aggregate demand is given by M times V, changes in either of these variables can also shift aggregate demand left or right. So for example, let's say we have an increase in the money supply. Then an increase here would lead to a larger quantity, so it would shift aggregate demand to the right. So in this example, let's say let's say initially we start off at point A. And so initially we have $800 billion in circulation. If we increase the quantity of money M from 800 to 820 billion, that increase in the money supply will shift the aggregate demand curve to the right. And similarly, if we have a decrease in the money supply, so initially starting off from 800 billion, now let's say we have only $780 billion in circulation. So in this case, a decrease in M would shift aggregate demand to the left. So an increase in either M or V will shift aggregate demand to the right, and a decrease in either variable will shift things to the left. Okay. So let's look at the idea of monetarism. So monetarists do not necessarily believe in the quantity theory of money. So here we said if we have a change in V velocity, it can shift things left or right. So recall with the quantity theory of money earlier, we said that if we were to put more money in circulation, it does not affect V. It only changes the price level. According to monetarists, however, they do not necessarily believe in the quantity theory of money, which assumes that velocity and output are constant. So the four positions that monetarists have is that first, velocity can change. It's not fixed, it's not constant. And velocity, in fact, changes in a predictable way in this perspective. So one way that velocity changes, so when we say that velocity changes in a predictable way, we're saying one way we can predict how velocity will change is based on how frequently we receive a paycheck. So for example, suppose if you're working, let's say you get paid twice a month. In that case, your spending would be higher than if you only got paid once a month. Um, so whether or not that's true, you can think about your own actions and if that would affect your spending. But the idea is when people are paid, they have this so, I mean, okay, I guess if you relate to this, oftentimes, even before we're paid, we may have an idea of what we want to do with that income or what we want to do with that money, even before we're paid. So it's like saying if you were to get paid twice a month, you'd have this feeling of treating yourself twice rather than if you only got paid once a month. It could be the same amount that you're paid overall. So let's say you're paid like $4,000 a month. So if you get paid twice a month, you're getting 2,000 each time versus getting all 4,000 all at once. So the idea is if you were to get paid twice a month and $2,000 each time rather than the 4,000 all at once, getting paid more frequently and receiving a paycheck more frequently would actually change your spending habits in that you would get the feeling of treating yourself twice as much in this case. So that's what we mean by velocity changes in a predictable way. So the more frequently you're paid, the more money you would spend, the more it would encourage you to spend. So money would change hands faster in such a way. The second monetarist position is that aggregate demand depends on the money supply and on velocity. So in chapter 11, we saw that Keynesians emphasized the role of government in influencing aggregate demand. So we know that aggregate demand is given by these four components of GDP. So remember, aggregate demand is the demand for everything that the economy produces, right? So it's just everything the economy produces is gross domestic product, which is given by these four components. So in the Keynesian perspective, Keynesians emphasize the role of government in influencing aggregate demand. So the idea is that, for example, if the government were to increase or decrease taxes, it could affect consumption, or the government could change government spending, which would also influence aggregate demand. In the monetarist idea, the perspective is that because aggregate demand is given by M times V, changes in either of these two variables can also influence aggregate demand. So for example, if we need to increase aggregate demand, we can increase the money supply or we can increase velocity. And then the third perspective is that the short run aggregate supply curve is upward sloping. So if you have real GDP on the x-axis and the price level on the y-axis, the short run aggregate supply curve is upward sloping, meaning output in the short run changes based on what the price level is. And then the fourth position that monetarists hold is that the economy is self-regulating. So this is because in monetarism, we believe that prices and wages are flexible. So anytime you have a shortage, then prices will go up. And prices in all forms. So prices, wages, interest rates. So for example, let's say there's a shortage of funds in the loanable funds market. So you have more people who want to borrow than people have saved. So if there's a shortage of funds, shortage of money that's available for loans, the idea is that interest rates will go up to encourage more people to save. And then also with a higher interest rate, the demand for these loans would decrease. So in essence, with the shortage, if interest rates go up, both with the quantity demanded going down and the quantity supply increasing, it will balance one another out until the two are equal. So similarly, anytime there's a surplus, prices will fall. So if we have excess inventory, we know that we would have to lower the prices in order to get rid of the surplus. So that's the idea here. So monetarists hold that the economy is self-regulating because they believe that prices and wages are flexible. So anytime there's a shortage, prices in all forms will go up, and anytime there's a surplus, prices in all forms will fall. Okay. So we said that monetarists believe that changes in M and V can change aggregate demand. So let's say we start off at a long run equilibrium. So here we're putting everything together. So this ties in the model of aggregate supply and aggregate demand that we looked at earlier, and then seeing what happens if we have a recessionary gap or an inflationary gap. So suppose we start off at a long run equilibrium. So this is our long run aggregate supply curve. This is the initial short run aggregate supply curve, SRS1. And then this is the initial aggregate demand curve, AD1. So we initially start off at 0.1 in this long run equilibrium. And then, so we start off at 0.1, and then suppose there's an increase in the money supply. So we start off here. If there's an increase in the money supply, we know that aggregate demand will shift to the right because of this formula. So if there's an increase in the money supply, then aggregate demand as a whole will shift to the right. So we start off at 0.1. We have an increase in the money supply, which will shift the aggregate demand curve from 81 to 82. So it shifts things right. Now we end up at 0.2 with this shift to the right of aggregate demand. And we can see at 0.2, the real GDP has gone up from this QN to Q1, and we also have a higher price level. So that makes sense. With more money in circulation, it's going to lead to higher prices. Okay, now at 0.2, we can see that real GDP is greater than natural real GDP. So this is an inflationary gap, saying that we're overproducing. So we should be producing at QN, this is the economy's potential or benchmark for where we should be. And if we're at Q1, we're overproducing. This indicates that the unemployment rate is lower than the natural rate. So remember, at the natural rate, the unemployment rate is like 5%. And if we're producing more than we expect, well, one reason can be because we have a lower unemployment rate than we expect. So one reason we're able to produce so much more is because more people are working and less people are unemployed. So at QN, if the unemployment rate is 5%, let's say at Q1, the unemployment rate is like 3%. So in this case, with the unemployment rate that's lower than the natural rate of 5%, this indicates we have a shortage of labor. So remember that the inflationary gap is the opposite of a recessionary gap. So in a recessionary gap, we typically have higher rates of unemployment than the natural rate of unemployment. So with inflationary gap, the unemployment rate is the opposite. It's lower than expected. So if the unemployment rate is lower than expected, it indicates that we have a shortage of labor, or we can say a shortage of available labor. So with such a low unemployment rate, most people who want to work are already working. So there are few people remaining to fill in vacant positions. So we don't have enough labor. So we're saying there's a shortage of available labor because most people who want to work are already working. So there are few people that are remaining to fill in new positions. So because monetarists believe that the economy is self-regulating, we said that over here. That was the fourth assumption. The economy is self-regulating. So because monetarists believe that the economy is self-regulating, a shortage of labor means that wages will go up. So because there's not enough people to fill in positions, these firms are going to have to offer higher wages. Well, now with higher wages, that's going to increase the costs of production. And an increase in input costs or an increase in cost of production will shift the short run aggregate supply curve to the left. So essentially, we start off at Qn and this point 1, and then an increase in the money supply will, for a short amount of time in the short run, it's going to throw us off from long run equilibrium and take us to an inflationary gap. And then because we have a shortage of labor, wages will have to go up to encourage people to fill in new positions. And then with the increase in wages, short run aggregate supply curve will shift to the left. And then again, the economy will come to a balance and come back on this long run aggregate supply curve at Qn. So in time, we're going to move back to natural real GDP, although it's going to be at the expense of a higher price level. And this occurs because of the change in the money supply. So what it's saying is the more money we have in circulation, simply it's going to lead to higher prices. Okay. Lastly, this is showing the loanable funds market model. So we've covered the loanable funds in various other contexts. So again, this model shows the supply and demand for loans and how interest rates will change as a result. So we're just covering it here because we've talked about money. So on the x-axis, we have the quantity of loanable funds, which is money that's available for loans. And on the y-axis, we have the price of money, which is the interest rate. So if you're taking out a loan, the price of that loan is the interest rate that you're paying on it. So the supply for loans comes, or the supply of loans comes from savers. These are the people who are providing the money that's available for loans because they are spending less than they earn. So they have money left over that they can give out as loans. And we can see that the supply curve is upward sloping because the higher the interest rate, the more incentive there is to save. And the demand for the loans comes from borrowers. So these are the people who demand the loans. And we can see that this is downward sloping because if the interest rate is really high, then few people will want to take out loans. So the demand for loans will be lower with higher interest rates. And as the interest rates fall, it's cheaper to borrow money, it's more affordable. So the demand for loans will increase. So the demand curve is downward sloping because the higher the interest rate, the less incentive there is to take out a loan. And as the interest rate falls, there's more and more incentive to take out a loan because it's cheaper and more affordable. So initially, we can see that the intersection of the supply and the demand curve shows the equilibrium interest rate here of I1. Okay, so that's the end of chapter 14. This is relatively short in terms of the topics that we're covering from this chapter. So we've looked at how the value of a dollar and the price level are related to one another. So they're essentially inverses or reciprocals. So the more expensive things are, the less each dollar is worth. Because you need more and more money to buy things, the more expensive things are. So that was one of the first takeaways that we saw. And then we looked at the velocity of money and how we can use that velocity equation to relate it to aggregate demand and the four components of GDP. So these are some of the takeaways from this chapter. All right. I hope you found this video useful. If you have any questions, please send me an email. Thank you so much.